delta, which we generally know as known as the nebula. We call it as nebula. So nebula is the notation for the backward difference operator. Now to define this backward difference operator, we write down the definition of this backward difference operator. It is similar to that of the forward difference but with a slight change. So whenever we apply it over a function, say fx, the result gives you fx minus f of x minus h. So this is your second operator, which is named as the backward difference operator, and we define it in the form of fx minus f of x minus h. If you apply it twicely, as we have done in the previous case, the result can be written as nebula into nebula times f of x. On applying the definition of the nebula, once in the bracket gives you f of x minus fx minus h, and this delta now nebula can now be distributed inside the bracket. It gives you nebula fx minus nebula fx minus h. On applying the first gives you fx minus h, and for the second I write it here and I place a bracket. On applying it, we get fx minus h, the original function, minus fx minus h, and there is a difference of one more h. Okay, now if we further simplify it, we can see here fx from this first term and fx minus h from here and fx minus h from here. So collectively it gives you 2 times f of x minus h, and this minus will change this sign of the inside minus, and it gives you x minus 2 times h. So this is the second time application of the backward difference operator. Now we develop a relation between the backward difference operator to the shift operator. Okay, now to construct the relation in between the backward difference to the shift operator, we write down from here the definition of the backward difference operator. I keep fx as it is, and for this function I can use the shift operator with the negative power for the function fx. So here we can take out 1 minus e inverse for fx, and dropping fx on both sides gives you nebula is equals to 1 minus e inverse. Or if we just readjust it, we can write it in the form of 1 minus nebula whole raised power minus 1. So this can be another format to express the relation between the shift operator to the backward difference operator. So this is your third operator we go through, and now we work on the next operator, which is named as the of course the forward, the backward, and now we work on the central difference. So here comes the central difference operator. And the notation for the central difference operator is a delta. This is another form of the delta, which is generally known as small delta. As we have alphabets, capital A and capital B, and small b. So here this is generally known as the small delta. Now we define this operator of the central difference operator. So here we write down the definition for the central difference operator. According to the definition, whenever you apply this operator over a function fx, the result takes the form fx plus h by 2 and minus fx minus h by 2. So this is the definition for the central difference operator. And if I apply it twicely over the same function, so the result takes the form delta fx, and according to the first definition, we can write it in the form of fx plus h by 2 minus fx minus h by 2, and the second distribution gives you delta fx plus h by 2 minus delta fx minus h by 2, and then you can further split it by using the definition of the center difference. The result takes the form fx plus h by 2 plus h by 2 minus x plus h by 2 minus h by 2. So this is your first two terms from this part, and from here we get two more terms, fx plus minus h by 2 plus h by 2 and minus fx minus h by 2 and minus h by 2. So here you can see a little complicated result here, and now we can simplify it. I am going to raise it to create a space here. Okay, now we apply the simplification of the last result. Gives you from here, if you look at it, so this gives you fx plus h by 2 is equals to f of x plus h, the first one. From the second, these two will be dropped down, we get fx, and these two will be dropped down from here, we get also fx. So collectively we have minus 2 times fx, and the last term gives you the plus sign here, and these two will be added, gives you f of x minus h. So this is the second time application of the central difference operator over the function fx. And on the same pattern, now we are generating a relation between the the central to the shift operator. So here we construct the relation between them. So we take start from the definition of the central difference operator, fx plus f of x. This is the definition, fx plus h by 2 minus f of x minus h by 2. So this is the definition for the central difference operator. So here we can write down the shift operator for 1 by 2 fx, and due to this we write down minus 1 by 2 fx. And if we take out fx outside, inside it gives you the result like this, and dropping fx on both sides gives you a relation in between the shift to the central difference operator. So this is your operator number 5. Now we work on another operator which is generally known as the averaging operator. Okay, so last operator we are going through. The next operator is the averaging operator. Okay, and now the notation for the average operator is a mu. You are already familiar with this notation. So here when apply it or a function, we get fx plus h by 2 and plus f of x minus h by 2, and one more thing, we have to take the average just divided by 2. So this is your definition for the averaging operator, and whenever you apply it twicely, we can simplify it on the same lines as we have done in the previous cases. So here we write down f of x, and the result takes the form mu of f of x plus h by 2 plus f of x minus h by 2 and whole divided by 2. And here this 1 by 2 can be taken out and mu can be distributed inside, gives you fx plus h by 2 plus mu times f of x minus h by 2, and on applying the first term gives you fx plus h by 2 plus h by 2 plus f of x plus h by 2 minus h by 2. These are the two terms we get from here, and don't forget to write 2 there. And from the second we get f of x plus minus h by 2, and then plus f of there is a few more terms